Hello, this is Nas from NB Network Lessons. Hope everyone is doing okay and having a fantastic day. Thank you for joining. Welcome. My today's topic of discussion is capacitor. What the heck is capacitor? You know, a lot of people know the word capacitor, but when you ask them what does it do, they're not really sure. But I would like to see if I can explain you what capacitor is and what is it used for. So this is my introduction lesson. So capacitor is basically just like inductor stores magnetic field. All right, when you pass current through it, it stores magnetic field. Capacitor, when you pass current through it, it stores electric field or electric charge, okay, which you can use or which you can bleed the charge at whatever time is necessary. So capacitor is really important, critical component in the world of circuits. Just about any electronics you have, your TV, your radio, your stereo set, your electronic toys, your computers, etc., 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 have capacitors in there, okay? So if you rip apart a circuit board, you will see not just one capacitor, but there would be several capacitors. And so like I said, it's really a critical part of electronics. And so I wanted to introduce that to you. So let's go ahead and dive into it and see, what does it look like? So if you look at capacitor, it kind of looks like this right here, okay? It's basically like a cylinder, okay? And then inside you have basically right here, you have two plates. This is a symbol of capacitor right here, okay? Some books have like this also, okay? But it doesn't really matter. This is a capacitor. So in a capacitor, basically you have two terminals. You have this terminal right here and this terminal right here. And in between there is a gap, okay? In between there is a gap, and this gap is basically filled with some sort of insulation, okay? In the world of electronics, they call it dielectric, okay? Dielectric. But basically, it's the same thing as insulation, okay? So there is insulation in this gap. Now, this insulation can be plastic. This insulation can be glass. This insulation can be rubber. This insulation can be some sort of material which is an insulator, okay? So keep that in mind, that two plates and in between is a insulator, okay? And the job of insulator is not to let the current pass, okay? So having said that, I'm gonna say, okay, so let's say we have this capacitor right here, okay? All right, I'm drawing a big. So by the way, unit of capacitor is farad, okay? F-A-R-A-D, okay? But in your circuit boards or in your electronics, you will never really see a farad. Because if we are talking about 20 farad, 30 farad, 40 farad capacitors, they're big as your room. They're big as like some houses. So when we talk about electronics, it's mostly microfarad, okay? Or picofarad, all right? Picofarad. So these are the most common microfarad and picofarad used in the world of electronics. Now back to capacitor. So you have plus, you have minus. So assumption is that current is going this way. All right. Now let me ask you this. I just told you that there is insulation between here, okay? So how is the current gonna pass? That's a valid question. I mean, in case of resistance, you have resistance, but current still can pass, right? Because there is material inside which is basically resisting the current, but not blocking it. Same thing in inductors. When you have coil like this, current is passing, all right, because it's a conductor, right? It does not stop the current to flow through them. But my question to you is that I just told you there is plastic, rubber, some sort of insulation in between. Then how is the current passing? Well, actually, in reality, current never really passes. So what happens is that when you pass the current through it, what it does is that it builds, let's say these plates are big plates, like maybe 10 feet long plates, okay, or maybe 20 feet long plates. So when you pass the current, what happens is that positive charge builds up right here. Positive, 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 these charges build up, okay, until there is no more room in the plate on the left-hand side. So what happens then? When you have positive charge right here, on the right hand, on this plate, you have atoms, right? Basically, everything has atom. This piece of paper has atom. This marker has compromises of atoms. So everything has atoms. And atoms have neutrons, protons. So in this particular case, there are electrons over here, right? There are electrons over here. There are protons over here. So basically, in the atom, you have positive charge as well negative charge. So what happens is that this positive charge becomes so powerful. Becomes so powerful that it repels the positive charge on the plate, on this plate right here. It repels the positive charge and pushes it out. So all you're left is basically negative, negative, negative over here. Negative charge, negative charge. So now this charge is going to stay there until we use it, until we bleed it. And like I said, in circuit analysis, if you have a circuit board, you have a TV, right? When you change the channel, okay, you're changing the frequency, right? So what happens is that for some frequencies, you need more capacitance. Other frequencies, you need less capacitance. So you change the capacitance. So you are basically tweaking the capacitor voltage at the time when you need it. So that's just one use of it, all right? So I hope I was pretty clear on this one. I will come back and we'll talk more about capacitors, but go ahead and watch this video a couple of times and see if it makes sense to you. It should make sense to you. If you have any questions, send me a message and I'll be happy to reply. Thank you so much for watching. Till next time, take care of yourself. Bye-bye.